the way I sort of got into it, I was talked into building a 8-valve Indian Altoona, and I was building an Anzani at that time. And the idea was I was going to make one each of those things, and that was the story. So the basic tooling I developed at that particular time was enough to make one of each. It got out of a bit of control, and we finished up making a total of 30 of them, the Indians and the Anzanis. So just shows you that once they start to work properly, people see them, it takes off. The way I started it off, I had a pair of Altoona crankcases, Indian crankcases, that sort of thing there, and a pair of Anzani crankcases, both damaged in a way, but what you can do is sort of patch things up, and then to make patterns, of course, you've got to put enough material in there so you can machine the things at the end. So this is where the old MDF comes in pretty handy.
Yeah.
This is a set of Jap crankcases ready to be made up as a pattern. You can see everywhere I'll put in the MDF in the things, thicken them up where they need to, put big bearings because I like big bearings, and that's where it starts. And there's a couple of good foundries now who'll take that with no arguments and produce crankcases to start off with. Then they finish up with crankcases like that, ready for machining.
And good wall thickness on
That's
everything
right.
too.
We thicken them up because in the early days, of course, they weren't turning out big horsepower. People were making them fairly light, and we now have the situation I just shown John before, dyno chart we've got here.
Yeah.
The Anzani, for instance, was turning out 30 horsepower in 1925, and the dyno chart he's got here shows that it was turning out now, that Anzani there is turning out 105 at the rear wheel, which is 130 horsepower. So we've gone up 100 horsepower in a few years, and they're still looking the same, you know. Now,
And still the same production techniques very much
same
too.
production techniques, as I say, that
No 3D printing or anything.
Yeah, because didn't get into CNC because, as I started off to say, I was only going to make one of each of these things, and just got out of control.
Sorry, Lindsay, what's the history of Anzani? Because I've actually never heard of them before.
Yes, Anzani was mostly an aircraft engine maker in the very early days. In fact, he built the engine that was the first thing to fly across the English Channel back in 1900. Blériot,
Yeah, 1909,
I think it was. Yeah. Pretty early.
8 or 9.
Yeah, in pretty early days. So he was pretty well into.
So British bike.
No, he was an Italian originally. Then he was a Frenchman, and then he became an Englishman. You know, so.
He was a bicycle racer, racing around the velodromes on the bicycles, like George Hendy, who with Indian, and then he got into making pacing motorcycles, the ones that used to sit in front of the cyclists going around the velodromes. So he made those, and then he got into racing bikes himself, and that one's got a 3-cylinder, they called it it's half a radial, but they called it a fan motor, and that's what Blériot had in his plane.
Right, yeah.
And I reckon he only got across the channel because he flew through some cloud and the cooling helped stopped it seizing. But but that's one of those motors, yeah. And these were used in aircraft as well.
Yeah, that's right, yeah. So that's the way you sort of get into making patterns. Cylinders, similar situation. Again, just make up as many fins as you like, bolt right through the centre. That's the cause for the actual cylinders, and that's the way the cylinder turns out at
That's
the
what
end.
it spits out. So there's two halves to the mould. There's a cope on the top and a drag, and that's why there's the part line along there. You can see the, but yeah, just machine that off.
Yeah.
How many fins you want, and put a sleeve in it.
Yeah.
So,
What sort of sleeve do you put out of steel?
Steel sleeves,
Cast iron.
sleeves, yeah.
And you notice they're quite thick at the bottom flange there, because a lot of people have problems with that. So if you can re-engineer something a little bit, just make it a little bit better.
Yeah.
So
in sort of, I guess, designing these things, you've got to stick with the outside look, But then you can play around with bearing sizes, put decent bearings in them, you know, all these old engines used to mostly have bushes into things like, you know. We also take the opportunity of dry sumping them so we can put plenty of lubrication through. So the bit stuck on the bottom there to for the small sump for
come back
the
out, yeah,
returning
so-
oil pump. Yeah.
So, in the end, sometimes with casting, you don't always get exactly what your pattern produces either, because you're using sand. These are sand cast, and you can see there's a fall away at the bottom there. That's actually meant to be straight across there, but most of that gets machined out anyway because that becomes part of the sump. So, yeah, but these are all sand cast, and that's how they would have been done. So Lindsay's tried to keep everything as original as possible. Will I talk about them?
Yeah.
All right. So this is one of Lindsay's finished heads. That's off a bike that's been used for years and on the track. But what he started, so it's 4-valve, all the ports, a branched exhaust as well, so 2 outlets on the exhaust. And on his Anzani ones, the Anzani, the Altoonas just have the 1 exhaust port. The Anzanis have the 2.
Did the Anzanis originally have a 4-valve head?
Yeah, they've still got a 4-valve head, the Altoonas.
No, the Anzanis, when
Yep.
they were in 1920 something, did they have a
Yep,
4-valve?
Yep. But that's what his pattern starts off with, and that's what Lindsay's made. Like, you've made over a dozen of these motors.
Yeah, 16 of them.
Yeah, and that's what the mould produced.
Yeah.
So he's got to create the combustion chamber, squish, all the ports, spark plug hole, gasket faces and everything, and he does it all by hand, like drills but I've seen him doing it, and it's basically clamped down. He bores this way and bores that way, but it's all done by hand to get to that stage. And with me trying to continue on with them, I'm not as skilled as that, and I thought I just thought I'll go a different way about it. And you could have had taken this head to a CNC machining place that could scan it, as you've probably seen now. They can run a scan tool over it, draw a program, and then set up a, 5 or 6 axis CNC machine to produce that out of 1 block. That costs a lot of money, but that's not how they made them back in the old days. Even though doing it that way, you get very uniform tolerances, and you can change anything. If you want to have a different valve angle or something like that, you can actually change it relatively easy. But I think these go well enough, and so we don't need to change it. So I employed a pattern maker to make some new patterns for me using that one as the original. So they produced this was Lindsay's original one that he made out of MDF as well. It's been cut up by a little bit by the pattern maker now. And so we used that and that to produce a resin copy, which he's cut some down, because then that produced this one that's in the box here. I'll just try and hold it up. And that's the one, it's got 2 runners where they pour the metal in. And the problem that was happening with some of these ones, they worked because Lindsay's used them for 20 years, but it wasn't producing all the ports and everything like that, and there was a bit of bubbling and things going on, but it was still worked. And then they produced this, and they made a core box. So just try and show you. The pattern makers are very clever. They think in reverse, and they think in negative space, and they think in production sequence. So that's part core box 1 of 3. And in this mould, this thing, to get to the finished head product or casting, there's about 9 different pieces that the foundryman has to work through, and put one in, take one out, put another one in, take that one out, make sure the sand doesn't collapse in the meantime, and they put gas through it to make it harden up. Some of you probably know about that, CO2. And then the finished product came out like that. So it's a lot more on the way to this one. There's about a millimetre more on every face, so you've got something to machine and still get it accurate. But the ports are already done and it's ready to have the valve, so it's cut and recessed with the spark plug hole and so forth. Yeah, I think, but it's still doing it the same way they would have done it originally, you know, as much as possible.
The shape of the cylinder heads are exactly as they were produced for their race motors back in 1922. I managed to find a guy in England at a swap meeting over there that had one of the original race motors, and he let me take photographs and drawings of the original heads. John mentioned that this engine was also used as an aircraft engine, so the fins ran across that way. The racing engines they went back to the motorcycle running fore and aft. So that was fortunate to be able to get that look at that time. And so there's only one race motor of the original type still around. This guy in England's got it, but we've now sort of reproduced the same thing. So people are accepting them pretty good. You know, I've had 4 engines go off to England and a couple more into Europe. So they're being accepted in Morgan cars. They're putting them in Morgan cars over there, and of course they're quite a bit different in the way of performance from their old bloody things. You know, going from 30 horsepower to 130 changes your world, doesn't it? You know.
I mean, they were record breakers when they were first built.
Yeah,
They were
yeah.
raced.
Claude Temple, that frame on that bike is a replica of the Claude Temple bike, which was made by OEC, Osborne Engineering Company in England. Claude Temple was the first guy to do 100 miles in an hour at Brooklyn Circuit, which was pretty good, and that was 1922. So riding one of those things at 100 mile an hour, well, he obviously was doing more than 100 mile an hour to get that sort of average, but pretty good sort of effort, you know. Yeah. Mm-hmm.
So that's Claude Temple there, and he went in, and that's his mate Michael McAvoy. McAvoy produced motorcycles as well, and they both produced motorcycles using the 8-valve Anzani motor. Both raced at Brooklands, but McAvoy was a Rolls-Royce employee at the time, so he had to sell them a bit under the counter. But part of what Lindsay's trying to show here is just how you can sort of produce things like that's a timing cover, you know, and it's just made up out of a wooden mould and get it cast and then machine it up. So a lot of handwork as well, but it can all be done.
Yeah. In the build-up, we take the opportunity to, in looking for performance, you've got to find out what's wrong with the original motor. And of course, with the Anzanis, I mentioned it before, but the crankcases were so thin, I reckon they were just like bloody saucepan lids, you know, in their actual thickness. So that's why we put plenty of padding in them to give them a bit of strength. Yeah.
Did you make those off an original Anzani crankcase?
Yes, yeah.
So how do you go, like, as I understand it, when you cast something, it shrinks, so you've got a certain amount of shrinkage
That's right.
to compensate for somehow?
That's where we put the thickness on. You can see there's a pad
And what
on
percentage
top
shrinkage
of
do you
that,
get?
and allow for machining too, of course, you know. And there's another piece in there to thicken up the crankcase. You'll find that that's nearly 25 mil thick now. In the original jab, it would have been, you know, maybe 10 mil or something like that, you know. Yeah.
So it's bigger on the outside,
Yeah.
and on the inside as well, so you can
Well,
machine it back.
yeah, we obviously this Anzani or jab or whatever, they're a little bit smaller. They're about 3% smaller than the original things at the end, because they are shrinking, of course, you know.
I think it's about 1 mil per 300 roughly
Yeah.
that it shrinks.
So you have to run smaller flywheels then, by the sounds of it.
Yeah, well, they're not that much smaller. You know, they had plenty of clearance in the original days, you know.
Right.
What flywheels we got in there?
Come on,
You want me to say
come
it,
on,
don't you?
Lindsay. Come on.
They've got rods and flywheels.
Yeah, that's right. We use Sportster, Harley.
What was that, Lindsay?
Harley Sportster, Harley. Sorry, got a sore throat. sports Harley, but made by S&S. So it's an easy way of doing it. They build beautiful
But that's-
crankshafts.
That's traditional, it's just improved a little
That's
bit.
right. That's right. Yeah.
You still bolt up.
Yeah.
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 You still have to make hardened valve seats and such.
Yeah. That all the stuff is mostly commercially available.
So you put inserts in.
What guide do you use?
Well, for instance, when I did my original research for the Indians and the Anzani, I was looking around for valves, and I was in a mate's workshop, and he had a Nissan Pulsar, and it had exactly the right size valves and right size guides. So that's what we use now, and we've never had any valve trouble or guide trouble. They just go on forever, like. Yeah. Which makes it, if you can get parts over the counter, it makes it much easier without having to machine everything, Yeah.
Unfortunately, but it's true, some of that Japanese stuff, straight off the shelf.
Yeah,
It's top quality,
Yeah.
7mm stems and things.
I've got to admit that most of the engine I made, I built had second-hand valves in, because the Pulsars used to crack the heads in about the first 100 kilometres, and most engine manufacturers or most engine repairers, they'd have 4 or 5 cylinder heads sitting up on the shelf where they change stuff,
You don't run a head gasket, do you?
No, we lap those cylinder heads to the barrel, yeah.
So do you make the valve seats, or you get them from a
No,
pump
these
or
commercial valve seats, yeah.
What degree is the motor?
58 or 57.5,
Yeah. It's a strange angle. It's 57 and a half degrees. How you'd ever come up with 57 and a half degrees when you're designing the original motor, and I can only assume that I did a bit of research on the thing, and that there was an original British Association thread that had a 57 and a half degree angle. So I think he must have been drawing nuts and bolts on the day, and that guy said, "Well, make it
Make a round cam, magneto.
make round cams." Yeah, you'll see examples of the cams here that I do.
Oh, the cam ring and that.
Yeah.
Magneto.
Well, it works, so you can't complain.
So you just like use a 60-degree magneto or something with a different cam ring in it, do you? Or?
Yeah, well, in fact, we cheat a little bit. They're closer to 60 degrees than 58 and a half, so we can use 60-degree magnetos, with a light touch on the cam rings.
Yeah.
In developing the motor, the original Anzani had 2 camshafts with rocker cam followers. I decided to go with direct operating tappets, and these are Triumph gears, so we just make a sort of a pattern like this to match all the gears up. That goes onto the crankcase like that, and then with my machine, my milling machine, I can just go straight through and make all the bearing places for it, and everything meshes beautifully, So.
And
That's a good way to do it.
instead of just bronze bushes on everything, all shafts have got roller bearings at each end.
Yeah.
So just
What oil pump do you use?
Okay, again with that, I mentioned the dry subbing before, you need to come up with an oil pump. So I use BSA B33, B32 oil pumps, report them, bring the ports out the side because they normally pump the oil out the end, and then I put them in a little housing like that, and that's driven at half engine speed with the both pumps working away in there. But good little oil pumps. There's thousands of those around at swap meetings, I don't know what happened to all the motors that they belong to, but they were
maybe
BSA,
Maybe not a good thing.
Same with other components, rockers. We just make up a pattern for those, go off to the foundry. Ideally, they would want to be in 1440 alloy steel, but most of them are now in SG, speed or graphite cast iron, and they seem to be no trouble at all. Fair bit of mucking around. You can see that goes from something like that was the original out of the pattern to a rocker like that.
You push them?
No, they're all on ball races. Yeah.
So did you say
You'll be able
you,
to see them in there.
Yeah.
You can see them in.
Yeah.
you say you use a Harley crankshaft?
Yes.
Yeah.
Yeah.
Oh, you got your cams?
Yes, well, I make my own cams. I've played with cams for all my life, and I don't say I know much about them, but I know how far you can go, so I've always tried to stretch the example of what I'm doing until they start to give trouble, and then just step back a couple of degrees, you know. But
Different overlaps.
yeah,
Yeah, how much overlap do you use?
well, I go for big duration on my cams, you know, and duration is the thing. It's what it's all about, you know. And you know, typically in the early days when this original Anzani was built, it probably had something like 200 degrees of total duration of the cam, when there are 320 degrees of duration. So, but they still, right, you know, the other example of that I've got at home, I had them just running in club rallies, you know, just on the race cams, and they're just plonked along. Cubic inches makes a difference to the way big things run, you know, and they're 1100 cc now, by the way, yeah.
I think in comparison, the XY had 75 degree overlap, but the GDHO had 150 degrees overlap, so that's even more.
That's right, yeah. Yeah.
And you're still using the cam grinder you made when you were 18, I think. Is that
Yeah,
correct?
I made a cam grinder because I was racing. I started off racing Triumphs. In fact, the first reproduction thing I made was a Triumph 3-bearing crankshaft Triumph, which is a bit of a trick on a Triumph, you know. I had to disguise it as an original Triumph to try and keep it okay for racing. But that won a couple of good state titles, and it was putting out good horsepower as just a plain old 650, but a 3-bearing one that I used to rev to 9,000 RPM, you know, on push rods.
Nice.
So I learned a lot about cams in the early days, you know. Yeah, I found out how far you could go. With the Triumphs, my biggest problem with valve springs. I couldn't fit good valve springs into things, but we've got good valve springs in these now that control it all pretty well. I've got to admit they're BMW valve springs, but that's pretty handy, you know. Yeah.
So basically, Lindsay's mixed and matched and worked out what he wanted, and then talking to him over time, he's worked out what he needs, and then he just goes hunting for it, finds something that's fairly common and readily available. And like all the bearing sizes all through it are just off-the-shelf bearings as well.
Yeah.
Like these parts, there's millions of them around, and
I didn't catch that drive. Is that still a pushrod motor or?
It's a push rod, yeah.
Yeah. So there's somewhere like.
but there's no rockers as such anymore. So it's just basically tappets running straight up
Just
onto
a
the
vertical
push
cam.
rods. From the cam's on the other side of here.
Okay, yeah.
Yeah.
Yep. And then you can see the push rods there just coming straight up.
Yeah.
Yeah.
I'd say basically solids.
Yeah.
I want one.
Well, that's what
Well,
he's
you
found.
might-
That's why he's been so busy.
That's why I went berserk, like, you know, and, you know, Katie was pretty okay to let me stay out in the workshop for many hours in the day, you know, but I enjoyed it. It was just good fun, like, you know, and I retired when I was 60, and so this was a good way of getting through the next 30 years, you know, and it's been good fun, yeah.
And
Now John's taken over the disaster, and Peter Berthissel's got the Indian side of the project,
yep.
so I can step back now, and I've got a new project coming, but you know, we'll talk about that
See what
later.
that is. How do you beat this? Where do you go from here?
But it's good to, you know, recreate history. Back in my racing days, I met up a guy at England. Ray Petty was a top Manx Norton tuner, and I worked for Ray for a bit of the winter period over there. And his father used to have a workshop at the Brooklyn Circuit back in 1920, and he knew all the guys, McAvoy, who had a workshop there.
You were saying that.
And they, you know, he used to tell me this. Those workshops, they used to do this all the time. They'd buy a Jap engine from the factory, and then they totally changed the thing inside until they could break the record. And of course, record breaking at Brooklyn's in those days was a major dollar earner. The guys would go out, each of the guys' temple, and then a few of the other guys would be talking to each other, want to go out and break their lap record by 1 second or 1.5 seconds and get a bonus from Shell Oil or Dunlop or whatever. he come back and his mate would go out and break that record by another mile an hour and get another bonus from the same companies. So it's a very competitive business.
Only do it by a little bit each time.
Right,
Yeah, because it's a gentleman's agreement
Yeah,
sort of thing.
yeah.
Because they'd get all the magazine press that next week, wouldn't
That's
they?
right,
You
yeah.
know?
It was important in those early days for the manufacturers, and there was a lot of manufacturers in those early days, to do something at Brooklands. That was the place to wave the flag.
And I think what I've caught from Lindsay about it is the history side of it, like finding out about Brooklands and who these characters were. And I know you know some of that stuff, Paul. And it's just interesting working out how they used to have their agreements, go racing, have a breakdown, pull another bike out sometimes, put the other badges on it, sort of thing, you
That's
know,
right.
and pretend it was that one, and off they go. And well, they might be in France up that big long straight. And but what I've caught, I think, off Lindsay a bit too is the making of the stuff, trying to think the way they thought and the way they were working it out back in the day, because they had basic tools like we've got in our workshops. It's incredible what Lindsay produces from his workshop. It's just basically a mill and a lathe, maybe a drill press, but you know, and that's basically what they had back in those days. And working with wood to then make your patterns, to then go to the foundry, talk to the foundryman and say this is what I want, and then heat treating, and then starting on doing the machining, and you either bugger it up or you'll make it into something, you know. So it's no good until you've actually done something with it, and it's really quite satisfying.
Yeah, true.
And the history's all tied in with it as well. So yeah. And I think Lindsay's been very, very successful. I tried to get this bike out of Lindsay for a long time, and he was lucky enough to get his original bike back, so that's how come I was able to then get it. And but I wanted to get it because I hopefully can keep continuing doing this. And I've seen them racing at the track. Peter Berthus will race them, Stan Mucha, and lots of other people, and I've seen these going around the track, and they're like when Lindsay said the horsepower figures, they're like a modern bike to ride.
Yeah. We're turning out the same horsepower as a Kawasaki 1100 or Suzuki 1100, which is
but in
pretty
a
satisfying.
rigid frame with girder forks.
Yeah, well, that's the
So
other tricky thing.
It's pretty exciting.
Yeah, 'cause
How does the frame handle it?
Yeah, I was going to say, but how's the
well,
slowing
yeah.
down?
Yeah, no disc brakes.
Yeah, don't worry about it, put your foot out.
well, the original Indian, Peter Arundel took it out to Lake Edna and Salt, 159.8 mile an hour on a rigid girder forked bike.
Yeah.
The another version of the Anzani did 158 mile an hour, exactly the same handling and all
Yep.
that. I've spent a fair bit of time on frames over the years, made bloody hundreds of them. So I've got a bit of a feeling what's okay, you know, and they feel pretty nice.
This frame's a bit different from your first one,
Yeah,
from
yeah,
your
yeah,
bike, isn't it?
yeah,
A little bit in different details.
Yeah.
And the forks?
Well,
You've played around with forks, but I think you've found that they perform really well.
Well, you know, majorly people say riding fast on girder forks is not a good idea, but these are obviously okay. But I've played with the geometry fair, but they're a little bit different to what girder forks are normally, you know, and they seem to work okay. Not much movement, you know, they're good for about 1.5 inches of travel.
Yeah.
But that's all you need, you know, and most of the road circuits are pretty good, smooth now, and of course Lake Edna on the Salt was even better, you know. Yeah.
And they're very light too. I reckon you probably only 150, 160 kilos. Pretty light.
Yeah, it makes a big difference. Yeah.
Yeah. It's a good power to weight ratio.
But Claude Temple's frame was a brilliant frame. You can see it's a double loop thing, not too far removed from a Featherbed Norton style of thing. It was all brazed in the early days, no lugs, so that's how he's able to keep it so light. And
So they did that in 1920 something?
yeah, 1922. Yeah. When you compare with a lot of the bikes in the club around the same era, 22, they're quite a bit different to what that was. You know. Yeah.
So they were purpose built though to do one thing.
Yeah.
What sort of compression ratio was the...
These are alcohol motors, so they're on about 11.5 to 1.
Oh, right.
Yeah. Yeah, they're 90 bore motors, so they've got a fair combustion chamber. You'll see the cylinder head when you have a look at it. It's quite a big combustion chamber. It's actually a copy of a Ducati. I borrow technology where I can. But
What gearbox is in it?
it's got a original Sturmey Archer, which is really a Norton gearbox. The gears in that go exactly the same as in the late model Norton. 4-speeders. We're restricted to 4-speed. Restriction on his bike race bikes. They've got to look the same as the original, and we went to a lot of trouble to get them right. We had a few arguments over things like bloody nuts and bolts are the wrong size, but mostly we managed to get them through. Yeah.
Can I ask, John, are you intending to build engines for methanol or for petrol?
I'd be probably either, really. Depends what. For racing, it'd be methanol,
Yeah.
much better,
Yeah.
more reliable.
Yeah.
Would it make a nice road bike, wouldn't it?
Yeah.
Yeah. Well, they make a good road bike. Yes.
Yeah.
Yeah. The one I ride now is the original bike that I got back from. I sold it to a guy in Queensland after I won the Australian Championships over at Mount Gambier. He came up to me in the pits with a big roll of money and said, "I want your bike," So I let it go. I didn't want to, but things you do for $1. And he had it for about 15 years on club registration, rode it everywhere. He reckons he'd done about 2,000 kilometres on the thing over that time. And then he got a little bit crook, wanted to get rid of it, so he sold it back to me, and at that time I passed that bike on to John. Yeah.
So the other one's on petrol, is it?
Yes, yeah.
And this one's back on petrol now too. It might go the other way.
So John, are you intending to make frames or just the engines?
No, I'll do frames later on too.
So